Hello and welcome back to my channel. In this tutorial I'm going to explain dilation and erosion example with OpenCV in Python. In image processing, dilation and erosion play a crucial role in tasks like image enhancement, noise reduction, and object segmentation. These operations are particularly valuable when working with binary or grayscale images, allowing us to manipulate pixel values based on their local neighborhood. In this tutorial, we'll explore what dilation and erosion are, their definitions, and how they are used in practice. This tutorial covers dilation, erosion, implementing in OpenCV, and conclusion. Let's get started. Dilation is an operation that expands the boundaries of objects in a binary image, increasing the size of foreground regions. It serves several purposes, such as joining broken parts of an object or making object more visible in an image. For each pixel in the image, dilation checks the surrounding neighborhood, typically defined by a kernel. If any pixel in the neighborhood is white, then central is set to white. This process results in the expansion of white regions, effective growing objects in the image. OpenCV provides dilate function to implement dilation operation to a given image. Here is the basic syntax of dilate function. Here we provide grayscale image as a source, and we define the kernel size. Then we set the iteration number. It defines the number of the times the dilation operation is applied. Erosion, on the other hand, is an operation that shrinks the boundaries of objects in a binary image, reducing the size of foreground regions. It commonly used for tasks such as noise removal or separating overlapping objects. Similar to dilation, erosion examines the neighborhood of each pixel. However, in erosion, if all pixels in the neighborhood are white, the central pixel remains white, otherwise it is set to black. This process erodes the white regions, making objects smaller and separating them from each other. OpenCV provides erode function to implement erosion operation to a given image. Here is the basic syntax of erode function. The same logic applies here. We provide the grayscale source image, then the kernel, then the iteration number. Now let's put theory into practice with an example using Python and OpenCV. Here we load the required libraries for this tutorial. Here we use OpenCV and Matplotlib libraries. We load image file in a grayscale mode. Then we define the kernel. Here we define the kernel with a 3x3 kernel. Then perform dilation using dilate function. Then erosion with the erode function, and we display the original dilated and eroded images. Here is the result. The first one is the original grayscale image. The second one is a dilated image. You can see there are a lot of white pixels here. And the third one is eroded image. There are a lot of black pixels. In this tutorial, we briefly explored the concepts of dilation and erosion and applied them to an image file using OpenCV. These operations serve as building blocks for more advanced image processing techniques and are an indispensable tool for enhancing and analyzing images in various applications. Understanding dilation and erosion is important when working on image segmentation, noise reduction, or object detection tasks in computer vision and image processing. That's it for this tutorial. In this tutorial, we briefly learned how to use dilation and erosion functions in OpenCV. I'll put the source code link right below this video. Please subscribe my channel and hit the like button if you like this video. Thank you for watching, and see you next time.